Welcome back. In the last video, we just discovered, or we actually just figured it out on our own, logically, that v final is v initial plus acceleration times time. And we showed that kind of intuitively. So if you realize it, this is kind of the first formula that ties together these variables to describe motion together, right? So I said that how do you describe motion? How do you describe someone's motion? Well, you can talk about their displacement, you can talk about their velocity, their time, and their acceleration. There's basically those four things. So this is the first formula that kind of puts it all together. It says, hey, if you want to figure out time, and you know these other three variables, you can do so. So there are actually four main formulas, and this one I showed you just using intuition, you can figure this out. But I'm just going to give you the other ones, and it's basically a manipulation of this first formula. So a lot of professors will take days to show the origins. I'm just going to give it to you, and we're going to still give you intuition. So this is one formula. The second formula is delta x. So delta x is your displacement, your change in distance, right? So your change in displacement is represented by delta x is equal to v initial times time plus 1/2 at squared. So again, another formula that kind of ties these different variables together. So time, you know, v initial, acceleration, and then this new variable delta x, which is displacement. And again, displacement is just delta x means change in distance in the x direction, right? That's what delta x means. So sometimes it'll say delta x, and sometimes it'll say delta y if you're changing your displacement in the y direction. But other than that, it's just either delta x or delta y. So you can also write a delta y version for this, but we'll get into that later. So let's just keep it simple. You have this one, this one. Another formula you have is v final squared minus v initial squared equals 2a times delta x. And the last formula is v average. So the average velocity equals v initial plus v final divided by 2. So these are called your four kinematics formulas. And what every kinematics problem is going to do is it's going to do this, right? So how do I describe motion? I already gave a hint, distance, speed, and time, right? But if we want to make it very granular and just very much define it, this is what a problem can ask you. It can say, give me the acceleration. Or it can say, tell me the v initial. Or it can say, give me the v final. It can say, give me the initial position, x initial. It can say, give me the final position. And then it can say, tell me the time. So every kinematics question is going to ask you to figure out one of or two of these variables. So it's going to say, tell me one of these variables. Tell me what is the acceleration. So tell me one of these. And how are you going to figure out one of these? One of these. And how are you going to figure those out? You're going to use one of these formulas to do so, right? So if it says, give me time, and you know these three other things, then you can figure out time. So this is the beauty of physics is there's only one or two strategies really per chapter that you need to master, right? It's not a bunch of memorization. It's if you see the big picture, they're going to ask you, tell me one of these, and how are you going to do that? You're going to use one of those formulas, or maybe a combination of those formulas. So you're going to use a formula to do so. So tell me one of these, and and use a formula. So usually a problem will give you some of these, right? It has to give you maybe this and this and this, for example, and then you can figure out the other ones. So how do you know which formula to use? I just said use these formulas, but how do I know which one to use? So I'm going to change colors. Exciting times. So people are going to say, oh, it's an art to figure out which one to use, and that's true. You really do need to practice, and the more you practice, you'll figure out which one to use. However, I'm going to give you a little bit of a couple shortcuts to make your life a little bit easier so you can get a little head start, right? So notice that this formula here does not have displacement anywhere in it. So there's no, I'm just going to keep it simple, no distance. Right? So if a problem is asking you, tell me the final position, don't use this formula, number one, because there's no distance in this formula. There's just velocities, acceleration, and time. Okay, what about the second one? This one has no v final. Okay, so by knowing what it does not have, you can actually start to get a good intuition on which ones to use. So if a problem asks you to figure out v final, don't use this formula, right? Let's go down here. This one is probably the most helpful, I think. There's no time in this formula. No time. V final squared minus V initial squared is 2a delta x. So how brilliant is that? That if you know the velocities and the acceleration, you can actually figure out the displacement without even knowing how long it took you to do all that. Okay? And this last one, truthfully, is like rarely used. This is just if you have to figure out the average velocity, you just go directly to this formula. And very few problems ever test this. So really, I mean, there's only really 3 formulas you need to know, but just know this 4th one as a backup. But yeah, I mean, this one is, okay, if they ask for V average, you just go straight to this. But here's your 3 main ones. So let's do some practice problems to see how we can apply this. Okay, so let me get this. All right, so let's think of some problems. So let's say, how should we do this? Well, let me switch colors again. So let's say I have a car. Okay, my car is going 20 meters per second to the right, so it's positive. That's its velocity, okay? And, well, let me write it up here. Okay, so it's going positive 20 meters per second to the right, and after a while, it is at 50 meters per second to the right, and I'll even tell you the acceleration. It was accelerating at a rate of 5 meters per second squared. And what are you going to say in your head? You're going to say it was accelerating at a rate of 5 meters per second per second. So every second, it bounced up 5 meters per second. Okay? And let's say it starts off at an initial position of 0. Let's just keep it simple, right? So you're starting at 0 meters. You're just starting. I'm not going to make it confusing, but you're just starting there, okay? So let's say the problem says find the final position and the time. Okay, so notice every problem in kinematics is going to give you some variables that describe motion, and then it's going to ask for the remaining variables to describe that motion. So if you have some, you can get the other. So what I like to do is, since every problem has this exact same approach, no matter what the problem just said, right? Let's say this made no sense to you. Don't worry. Every kinematics problem, always write down 6 things. What is the acceleration, your V initial, V final, X initial, X final, and time. 6 things. Every problem, there's only 6 ways to describe motion, so you might as well write out all 6, and then whatever you know, plug it in, and whatever you don't know, put a question mark. Okay? So, do we know the acceleration? We do. It is 5 meters per second per second. Do we know the initial velocity? It is 20. Do we know the final velocity? It is 50. Do we know the initial? It's 0 meters. Do we know the final position? We don't. And do we know time? We don't. So just organize it, like this, right? Your 6 things, because it's nice to draw a picture, but then also just write it out. Bam. These are the 6 things they want. 2 of them I don't know, 4 I have. So how am I going to figure out X final and time? Well, we will use our 4 kinematics equations to do so. So, to figure out time actually, before we even use the formulas, can we figure it out intuitively? Let's think about it. If I'm starting at 20 and I got to 50, right? So I went from 20 to 50, and I know that every second I went up 5 meters per second, right? Remember, you want to read this as 5 meters per second per second. This is how you want to read it in your head. So if I started at 20 and I need to get to 50, and every second I bounced up 5 meters per second, So after 1 second, I was at 25. At 2 seconds, I was at 30. And then 35, 40, 45, 50. So actually, without doing any equations, I can already tell you that it's going to take me 6 seconds to go from 20 to 50 if I'm going at 5 meters per second every second. How cool is that, right? So use your intuition, because when you use your intuition, you cannot go wrong. At the same time, your teacher is going to want to see some work. So we also have to use the formula. So let's see. How do I figure out time? Well, there are only two equations that have time in it. V final equals V initial plus AT. And then delta x equals V initial t plus 1/2 AT squared. Okay? The last one, let's just write it out here just so you see it. V final squared minus V initial squared equals 2a delta x. There's no time, so I cannot use this right now. Let's not cross it out. But you can't use this right now because there's no time. So I have to use this one or this one. So how do I pick? Well, truthfully, you can do either one, right? Well, let's see. Actually, you cannot do this one, delta x, because delta x is, your change in distance is always x final minus x initial. And you don't know your x final. So actually, you don't know x final and you don't know time, so this would be a bad one to use. So, but sometimes you can just use either one. So it's not always an exact science in that sense. So this one is the clear winner, and it's usually a nice and simple one, right? So it's got everything. So what's V final? 50 equals 20 plus 5t. So 30 equals 5t. T equals 6 seconds. Awesome. Now this is no longer question mark. It is 6 seconds. We know it. Let's get x final. How am I going to get x final? Again, there are only two equations that have displacement in it, right? This one does not have displacement. Notice, no displacement. So you can't use this. So you either have to use this one up here or this one down here. And in this situation, let's see, you can actually use either one, right? You know V final, you know V initial, you know acceleration, and you know, well, you don't know the x final, but that's your one variable. Or you can use this one down here. You know, since you know time, you just figured out time, so now you can plug in the time here. You can use this. I don't know why I like this equation slightly better, because there's only one t squared, and this one has square, square. I don't know, more room for error, but you can truthfully use either one. So I'm going to pull this here. So we're going to use this one. So delta x, again, is x final minus x initial, which is 0, equals V initial is 20 times your time is 6 plus 1/2, your acceleration is 5, and your time again is 6 squared. So 20 times 6 is 120 plus 6 squared is 36 divided by 2 is 18. 18 times 5 is 90. So if I did my math right, this should be 210 meters. That is your x final. Cool.